In this video I will show you how you can run a regression with cluster-robust standard errors in SPSS. If you have nested data or clustered data, then you will have a problem using ordinary least squares regression, because your standard errors, your test statistics and your p-values will be wrong, because OLS regression doesn't take into account the clustering of the data, and thereby the so-called independence assumption will be violated. This can arise in a cross-sectional design, for instance, students nested within classrooms, or it can arise in panel data, for instance, time points nested within persons. A common solution for this problem in SPSS is using multilevel modeling or linear mixed effects modeling. However, that can be quite complicated, and there is an easier alternative: cluster-robust standard errors. That is, an ordinary least squares regression where only the standard errors and thereby the test statistics and p-values are adjusted to take into account the nested data structure. To do that in SPSS, you download Hayes process macro. I've put a link to this great tool in the video description, and the newest version, version 5, which is still in its beta phase, can not only analyze mediation and moderation models, but also multiple regressions with cluster-robust standard errors. If you download process, in the folder SPSS you will find a file you can use to install a custom dialog box using this option in the submenu extensions. After having done that, you can go to Analyze, Regression and then to Process, and you will get a dialog something like this. Y variable, there is your dependent variable. X variables are your independent variables. Model number for multiple regression is 0. And then the crucial part, standard errors. Here you choose cluster robust, and as a cluster variable, the variable that defines your clusters. In this example, it's about students nested within classes, so here the cluster variable is the class identification number. Then you can click on Run. Paste doesn't work with process. First, some general information about the number and size of the clusters, and then the regression results. It looks like any normal regression with one crucial difference. Here in parentheses, CR. That stands for cluster robust. That is, the standard errors and the test statistics in this output are corrected for the clustering of the data, that we have students clustered within classes. So these values are correct even though we have nested data. And in the analysis notes you can see that a cluster robust standard error was used. That's it. Thanks for watching and see you in the next video.